Ladies and gentlemen, please welcome to the stage Vice President Worldwide Public Sector Sales, Teresa Carlson.
Hey! How are you? How's your day? How's your day, huh? It's good to see you all. All right, I hope you're ready for the best presentation ever. Brought my clicker. Hope you're ready for the best presentation ever. Tom Sostrom is so amazing, and he has been one of our early customers, and he's the IT Chief Technology Officer at NASA JPL, so the NASA Jet Propulsion Laboratory. He's been long recognized as one of the powers in the cloud to transform the mission of the agency. And I'm proud to say that Tom really has been one of our very first customers in the public sector since 2010. In fact, sometimes I do call him the father of our GovCloud because he actually was the one that came to us and said, you guys need this ITAR cloud. And they've also been described, I don't know if you've ever been out to NASA JPL, but they're really described as an 80-year-old startup. And like any good startup, they prioritize rapid experimentation at a low cost at all quest of reaching whatever new heights. And their bold commitment to innovation has led NASA JPL to send robots to every planet in the solar system. Can you imagine every planet in the solar system? And they've used AWS to capture and store images and metadata collected from the Mars Exploration Rover, pictured right here. The lessons that Tom's about to share for any public sector organization, both here on Earth and those that are exploring the stars. And one of the things I wanted to share that's very personal with you is that the last 2 years at reInvent, Tom has worked with us to bring students to reInvent and do modeling for them. We've done everything from robotics to just technology discussions. And they love Tom. The students ask him so many questions, and he's always so amazing with them and patient, answering their questions and getting them really excited about space exploration. So it's my honor again, and by the way, Tom was our very first speaker at our very first reInvent in Las Vegas. So now it's really a pleasure to have him back with us here today. And if you haven't downloaded the AWS app, please download it, because he's going to be doing real-time voting. So you're going to vote on the things that you want to see next with Tom. So again, it is my pleasure and my honor to welcome Tom Soderstrom to the stage, the Chief Innovation Technical Officer for NASA JPL. Please put your hands together. Woo! Here you go. Go get it.
Thank you. The things you do to get a hug from Teresa. So, you're all, pretty much all of you are technical. You're all experimenters. You live on the edge. So we're going to live on the edge today. Just to let you know, I've never done this before. AWS has never done this before. So I figured with a cozy little crowd like this, why not try something new? What could possibly go wrong? So usually I ask you to not use your cell phones because we're doing some kind of experiment, but this time you will use your cell phones. So we're going to do some voting. I am your puppet. You will direct me where you want me to talk, and we'll see how that works. But before that, by the way, that's JPL. JPL is kind of like a small city of 6,000 people. That's our physical, if we can go back, that's our physical workplace, but our head is in space. That's what we really think. We're in the foothills of California, and I'm in IT. I innovate in IT, I work in IT, and I love space. So why do we do what we do? This is why. It's to answer those big questions that affect humanity. Is there life in space? Can we protect Mother Earth? How did the universe form? Where is it going? Can we find Earth 2.0 if we one day needed to find a place to go? So as we talk about the IT experiments, that's really why we're doing what we're doing. And you're the ones who's going to drive us there, so thank you. We had a busy May, very busy May. We launched 7 missions. That's a record for us. And of course, we're pretty new. We've only been around for 80 years. We are an 80-year-old startup. It's a very innovative entrepreneurial culture, just like you all. What you see here is unusual. Not only 7 missions, but on here is three CubeSats, Earth-observing CubeSats. A CubeSat is about this big, and it's a real spacecraft. And it's really been driven by your smartphones, the miniaturization that's coming so we can fit more technology in less space to answer those big questions. We're also sending Marco. It is a CubeSat that's going to Mars. It's about 150 million miles away. Not bad for a little box. And we'll talk more about that. The one, Grace follow-on, it's 2 spacecraft that are traveling together, and the gravity of the Earth changes the distance by millimeters. And from there, we can tell how much water is in the Earth or in the ice. So pretty interesting stuff. So we look at technology as coming in waves, giant waves. And there's waves coming, so how do you decide which ones to surf? That's really the key. So we look at enjoying the benefits of surfing. That's the end user experience and IT speak. And of course, the power of the wave. That's the infrastructure. And then the biggest one of all is spending time doing it, having the priorities. So we're going to teach ourselves to surf and hopefully our stakeholders. And if you look carefully, you'll recognize curiosity. And if we one day found enough ice on Mars, water on Mars to surf, that'd be a pretty cool thing. What is this? Anybody? It's Sydney. What else is it? It's a bunch of what this guy invented 100 years ago. If Edison had thought about that one day it would drive the world and light up Sydney and every other city, would he have just been overwhelmed by the magnitude of it? I think he would have. So the point is, we need to experiment, we need to try new things all the time, like we're about to do. And if we fail today, it's okay, nobody's going to die. I'll be embarrassed, but that's all right. So if we look at the technology waves, and I'm going to share them with you in a second, there's one, they all build to one giant tsunami. Anybody guess what that is? You probably guessed it. It's AI. It's built-in intelligence everywhere. And given that I'm going to tie this together with the cloud, because of all these technology waves, cloud is really the enabler. It's where we work when we're not in space. So first of all, how do we interact with the computing environment today? We use whiteboards. They may be digital whiteboards today, or they may be databases, but there's lots and lots of data, and we need to do that to collaborate. The difference is this. We will now interact with them naturally. If you're old enough, Star Trek once had an episode where Scotty went back to Earth, and he wanted to use the computer, so he picked up a mouse, and he said, "Computer." That has become reality, and I'm going to show some experiments there, where we can actually now, we can type, of course, we can click, we can touch big touch screens, we can hear using our senses, we can speak using Alexa or any of the other ones, we can gesture, we can use our smart glasses to see and blink, and soon we'll be able to think. And all the sensors everywhere is really making us into augmented humans. So the user experience, enjoy the benefits of surfing, is there. So what happens? Where's the data? The data is everything. So we need to have the data in data lakes, and I'll show some examples of that. And the API is the new programming language. Hopefully you're all paying attention to APIs, because that's where it's going. So now you can ask questions, and you can get information from the data, but that's only the beginning, and it's a very early start. Here's the magic. It's AI. It's machine learning, and it's deep learning, and it's adding all that on the background once you have your user experience. And if you see intelligent assistants, That is really key, because we believe it's human in the middle. And I'll talk quite a bit about that more. And AI gets better and better over time. So, what are the 6 technology waves? I'm going to now get ready, get your phones out, because you're about to vote early and often. So these are the 6 waves. They are, you're all technology people. Let's geek out. So this is what it really means. It means cybersecurity challenges, and you can see what, I'm going to ask you to vote which ones you prefer me to talk more about here in a minute. It's authentication, it's encryption, it's blockchain, it's all of those things. Accelerated computing, it's really amazing what we can do now. The power of your smartphone, it's driven as smart self-driving cars by GPUs, high-performance computing, serverless and edge computing. Hopefully you're deep into that, because that is truly the future. Software-defined everything. Everything is becoming a programming problem, where we may, if I asked you to raise your hands, probably half would say you're programmers. Next year, you would all say you're programmers, because the programming is changing. We program our 3D printers to create new materials. That's a type of programming. It's also about software-defined networks, probably the biggest innovation for us. It's not just our network, it's not just AWS's networks, it's all the networks. Ubiquitous computing. It is taking advantage of your second brain, which is always with you, and about smart devices like the smart watch. Augmented reality is changing dramatically, and of course, Internet of Things. And I mentioned natural user interfaces. Then there is applied AI, and it's kind of what you expect it to be, but much more and much bigger. Then new habits. It's really the millennials entering the workforce, cutting the cords, not having fixed phone lines, not having fixed cable TV, applying that into the enterprise. It's a sharing economy. It's also about a reduced footprint overall. So those are the 6 technology waves. So now we're going to do a little vote here. First of all, I love space. I love technology. I love both. What do you like? So we're going to ask you to vote. So if you take out your phone, and hopefully you have the AWS Summit app open, and if you do that, you look at in the upper left-hand corner, and then you select schedule, and you select this time slot, which is 4 p.m. And then, catching up to you here, you click on that, and then you scroll down and you click on poll 1, the first poll. So let's see if you want to hear about space missions, if you want to hear about emerging technology trends and the results of all of our experiments that we've done, and if you want to hear about both of them. So let's start voting, and we'll give it a little bit of time. I wish I could see how many people are voting. So this was finished about 5 minutes ago. So you guys are experimenters. And I love that AWS is daring to dare mighty things, and we are too. So I think the audience has spoken. 47% want to hear both. 34% want to hear emerging experiments. And then 20% want to hear about NASA space mission. So I'll adjust the time, and now we'll get to the next poll. Of those technology waves, which ones are you more interested in? So you exit the poll, you go to poll number 2, and then you can pick multiple. So pick the ones you're interested in, and we will talk about which ones to do. Give this a little bit of time. Huh? It's either poll 2 or poll 3. It's the second out of 2 polls. Clear as mud? If we find mud on, thank you. So see who won the Oscars here. All right. So how's it looking? Okay, AI, it's a big deal. Ubiquitous computing, software-defined everything. So what I'm going to do is I'm going to cover these in order until we run out of time. But I am going to speak about space missions too. So Danny backstage is going to click, because I can't do my own clicking. So I think, are you all done voting, or you want to spend more time? You guys are quick. All right. Let's get started. We're going to do applied AI, ubiquitous computing. Can you see this? No, you can't see it. So 32% applied AI, 17% ubiquitous computing, 16% software-defined everything, and then about equal for the rest of them. So let's start with applied AI. So what are we talking about? So if we look at, I wanted to do just a little bit. You're probably way beyond this in your usage. But if you look at what is AI, is it the one that's going to make us all jobless and recreate the the bread lines in the 1930s in New York? No, that's just science fiction. It's stupid. Is it the one where Arnold is going to come down and kill us all with Skynet? No, that's not what we're talking about. That's sensationalist stuff. What we are talking about is narrow AI. It's the one that is actually having self-driving cars. By the way, out of curiosity, clap your hand if you have a Tesla. A couple of you. Clap your hand if you're using it self-driving on the freeway. Oh, he already died. No. The point is, it's coming very quickly, and it's doing extremely well. So self-driving cars, it's a revolution. It's fantastic. So that's the AI we're talking about. And even more so, the AI that's going to help us cure cancer or detect cancer. Humans are about 80% effective. Computers or AI is about 80% effective. When you combine them, it's about 95% effective. So it's about intelligent assistance. So if you look at these industries, if you are in this industry, you are being disrupted right now. If you're not, it's your opportunity to get an early mover advantage. So what kind of things, why AI? So if you look at the numbers, lift in revenues, sales growth, the startups, if you're a startup, you're going to be gobbled up by one of the big guys, and that's a good thing, having done a few startups. And there's going to be lots and lots and lots of data. And why now? Because the conditions exist, finally, and they're important. There are success stories that we can talk about with our board of directors. There is compute power and data. And where is the compute power and data? It's in the cloud. So what you can do is you can take and train all these algorithms and get them ready and then deploy them on smaller computers, whatever they happen to be. And open source. Open source is a fantastic thing, and it can run in the cloud. And that's how we do a lot of our experiments. And finally, skills. So skills is something, if I were to ask you today how many people are doing AI, I'll get a few of you. Next year, probably all of you. And chances are you'll be using SageMaker. So there's a tremendous opportunity here to get started. So here's, if you want to try to figure out where to get started, we looked at this, and we get started in a few of them. I gave a few examples. This is where we are in red today. So we're doing a lot of AI in various areas, but it's really about the intelligent assistance. And I'm going to show a couple of examples. If you're a business manager and you're thinking about where should I pay attention, here's where you should pay attention. The deep learning, and especially reinforcement learning. So we did that at JPL. We got the group together and said, we want to learn about reinforcement learning. You programmer, you're interested, go figure it out and teach everybody else. And that method works, because at least you get started. Start where? You can start in any of these. AWS, Microsoft, others, Google. The point is, get started. And you can run, for instance, you could run TensorFlow in AWS Cloud. So it's a very collaborative environment. And of course, we're very excited about SageMaker and recognition, as I'll show in a second. But industry, as you can see on the lower left here, there is Waymo, Google's self-driving car unit, spun it out as a business. Machine learning and stocks. Which machine learning is the best algorithm to pick stocks? Doesn't matter. They were all better than the human. The one in the middle is interesting to us because that's, it actually is a fastener over the river, a river in The Hague. And the one to the number 3 there is designed by AI. It weighs 50% and it costs 70%, 75% less, and it holds the same weight. So I used to talk to our mechanical engineers and they would say, well, who cares? You can't build that. But you can. Now you can 3D print it in metal, and so it's all coming together, these exponential curves. I love the one on the right. Anybody heard of the Turing test? Can the computer trick you into thinking it's a human? And yes, it can. At Georgia Tech, it was broken. This teacher's assistant named Jill Watson, a little clue there, was actually a digital assistant and nobody knew because she answered the questions 97% of the time correctly. So it's really an amazing time to take advantage of it. So we did a brainstorming session at JPL. We wanted to take advantage of these chatbots. What could we do? So even though our world, our thoughts are in space, we still have to meet. We have to find a conference room. So that became the number 1. So we came up with that, did a brainstorming session. So we used crowdsourcing, gamification, and we came up with that that's the number 1. And then later that night, we built it. That's how quick this is. So how do you build it? You go after the data. Where is the data? And then you pragmatically figure out what can we do. And then what we did is we were able to get it better and better and better over time because you could now text to it, or you could type to it, or you could speak to it through Alexa. And on the back end, if you're able to read that, it's adding AI over time and making it better and better and better. But your user experience doesn't change, which means you can get started right away. That was a real lesson learned for us. And then it doesn't have to be finished. It doesn't have to be completed. You can just leave it there, make it better, and get the users to give a thumbs up or thumbs down. And you mine the thumbs down and figure out where the priorities are and just iterate it and iterate it. To you who are probably in some smaller companies too, it seems like, of course you would. To an enterprise, it's a big deal. This is a very different way of working for us and much faster. So here's some of the digital assistants or chatbots that we've already done. And they're coming fast and they're very effective. So if there's one takeaway from here, when you get home to your office or even tonight, think about an intelligent digital assistant that helps the humans, a chatbot, because they're easy to implement and they're fast and they deliver value right away. So then we said, could we use face recognition? So we had an IT Expo event and we decided to try it out. So one of our developers, just in less than a day, wrote use recognition. And that's my badge picture down there. It's 11 years old, and it's as fuzzy as it looks. And it found me 90% of the time. It detected a 90% match. It even told 2 identical twins apart. And this is with 1 day's worth of development. Then we said, OK, could we use it for counting people? So we had an event, and 1,000 of the 6,000 people are walking through tents. We put some very cheap devices, about $100 each in total, counting down on the heads they were moving. And we're able to find, at 85% accuracy, where they were. So we were now able to tell when it's the busiest time. You can see at 9:30 and 10:30 is the busiest time. At most, there were about 500 people in the tent, etc. It's remarkable. And that's with just part-time of a week of development, using the tools that are already there. Now, can we use it for space? Yes, we can. So this is SMAP. The Soil and Moisture Active Passive is going around Earth looking at water every 90 minutes. And it has about 4 billion values. And if you look at these two, you're smart people, you obviously see where the anomalies are between the predicted and the actual. Not so easy. But it is for a computer using AI. So doing that, we're able to using AI to find where they are, and then do a user interface, the intelligent assistant, that tells the real experts where they should focus their time. deeper color, more anomalies. We've done several of them, and they are coming very quickly. I like the one detecting interesting rocks on Mars, because it's sitting on curiosity as it's driving. If the people missed something that the AI says, this is an interesting rock, it takes a picture, it sends an image down to the humans, and they can then turn the rover around and drill into it if they want. We use a lot with chatbots, derived credential on the front end, and let's see, yeah, cybersecurity was not one of your selected ones, so I'll very quickly say, we're creating a way of being able to instead of plugging your badge into the computer and type in like we have to do, just getting close to it and deriving the credentials from your smartphone. Again, your second brain, to make it easy, and then you type in a PIN. On the back end, denial of service attacks, AI is looking for them, helping us mitigate them. Thank goodness. So the second one that you were most interested in was ubiquitous computing. So let's go there, Danny. So IoT is a huge deal. Internet of Things is driving the industry. And it is fleet management. There's 20 million fleet management systems already. Self-driving trucks doing analytics and preventive maintenance all over the place. Very interesting. So what we looked at is, for Internet of Things, we're already using augmented reality on Mars. Actually, it's running on Earth, but you look like you're walking around Mars. And you can have these goggles. Fantastic, works wonderfully, if you have the goggles. So here's the interesting thing. With using your second brain, smartphone, now you can take augmented reality with you. So what you can see is you can go in. I asked a friend at JPL, show me something. So this video is of me using the smartphone in the conference room, just scanning, creating an image. And this is, all of a sudden, curiosity is in the room using augmented reality. Then he said, that you can see me walking through and looking at it. We now build spacecraft that way. We're using augmented reality to check it out. At the same time, he said, I'll show you something different. And again, this is that same night he built that. He said, what if I could build you a portal from that conference room into Mars? So now I'm using my smartphone, and I'm seeing the portal, and I'm just walking onto the surface of Mars. And I'm turning around, and when it's finished, I walk back out. That could be another business unit, it could be another country. For us, it's a different planet. All kinds of possibilities now that augmented reality is on a smartphone and on your glasses. We use gamification to write apps to find parking. That's another difficult thing for us. Not on Mars. There's plenty of parking up there. Here's some of the other experiments. We control robots using voice. And if you think about three networking things, you didn't pick accelerated computing. So think about 5G, 802.11.ax, and Bluetooth 5. All of them are about Internet of Things, handling millions and millions of devices. So the computing is accelerating tremendously. So we're going to see more of these. So if you have an Echo at home, install this software. It's very complicated. If you say, Alexa, enable NASA Mars, and you're done. You just installed it. Now you can ask questions about Mars. So we thought that was very cool. First NASA Alexa app. But then we realized it's really using serverless computing. Serverless computing was 100 times less expensive than our normal way of doing it. So we have since transitioned and are now doing serverless computing on everything that we can. It really means don't worry about how it's solved, worry about what you're trying to solve. That's what it means to us, and it's very powerful. This is, okay, if we can turn the sound up on this one, please.
What is the APO for subcontract 1525702?
Okay, we can turn the sound.
The associated PO number is 1563270.
I'll be Alexa. So she said, Alexa, find me this requisition. And Alexa answered, OK. And it came back with an answer in less than 20 seconds. The old way of doing things is much slower, and it's once you don't remember the password or where the data is located, it takes forever to figure it out. Whereas if you just focus on your problem, I want to find out about this acquisition, it's very easy. So it was 10 times faster. We answered all the questions correctly. We were proud and happy. But the users were not happy. Why not? That's the user satisfaction. We measured it built in. Because you don't speak the way you type. You're having a conversation. So that's about the natural user interface. So we switched it to say, Alexa, I want to know about acquisitions. OK, what do you want to know? I can tell you this, this, or this. And it changed everything. So that's the other part about the interface, that you can use it, but it's a dialogue. So let's cover the next one in order here was software-defined everything. So let's pick that. I'm going to go through that a little quickly so I can get to space. This is probably obvious to you all, but it's not so obvious to an enterprise. Programming, open source, DevOps, APIs may be the thing you're missing. It is the new programming language. It is the thing to keep in touch of. And then software-defined networks, it is really probably the most revolutionary thing we're doing, and we're going there. If you have ever heard Netflix speak about their self-healing network, fabulous idea. So we are now using the open source mentality inside JPL. We're sharing code just like you would in open source. And it's led to 100% reuse, 100% improvement, saves money, containers, automation, and of course the self-healing networks. Things that you're hopefully already doing, but it's quite dramatic. That's our roadmap. So we will have the software-defined network, I hope, and intelligently self-healing. So let's switch to space. Let's talk about space. So we talked about the three things you wanted to hear about: applied AI, ubiquitous computing, software-defined everything. We also had accelerated computing, cybersecurity challenges, and new habits. We can talk about that anytime you want, but that's what you wanted to hear about. So if we can go to the end here, please. Thank you. You know, we found that this process works. It's experimenting. It's making it fun and light, just like we're doing today. Iterating towards it. That's the process. Focus on that. The data is really the key. And then if anybody in cybersecurity, clap your hands. Okay, everybody else, whoever clapped their hands, hug them. You need to be their friends, because that's how we're going to drive this faster. Invite cybersecurity to participate in all the experiments right away. Otherwise, they can't shut them down. And they will, won't they, Matt? The other thing is the technology. It's the things that you would expect it to be. It's open sourcing cloud computing. We're using crowdsourcing now internally and externally. And it's the combinations of things. So think intelligent assistants. Always remember our key priorities. And you know who this is? And what he said? It actually was not Spider-Man who said this. It was Voltaire. With great power comes great responsibility. You have great power. You have a responsibility to move forward. Just like the great white shark, any enterprise that stops moving forward dies. And you have the power to make sure that doesn't happen. So where do you want to go tomorrow? We talked about these. That's what we did in May, so long ago. This one is, you're going to hear about these, SWAT and NISAR. One with the Indian Space Agency, one with the French Space Agency, and NASA. Those two instruments that will circle the Earth looking for water, their radars, will collect more data, 100 times more data than everything we did before. So it sure was a good thing we began playing with cloud computing 11 years ago when it was still a toy. So experimenting with things to think about the business is key. Europa. Europa is a planet of Jupiter. It has much more water than Earth. And as you can see on this picture, it has energy. that there's no craters, so something is moving around. There's water, and there's a huge ice sheet with lakes in it that we think is a likely place to house life. So we're going there. We're going to orbit and find a likely landing place, one day land, and then one day become a submarine or drill into those ice lakes to look for life. Mars. How do we prepare Mars for humans or humans for Mars? InSight is one of the ones that launched in May. It's going to land on Thanksgiving, and it will drill into the ground at Mars. It's a lander, and it will detect earthquakes or Mars quakes, if there are any, tectonic plates, things like that, to try to understand Mars much better. It's really exciting. Did you hear about this? This is so cool. We found organic matter on Mars. We've been looking at it for a long time. So we finally found methane, found it on the ground, and we also, this is about 2 weeks ago, found it that there's cyclical. It has cycles. So what replenishes the organic material, methane? We don't know. But boy, are we going to try to find out. This is really exciting. This is another thing you may have heard of. When Matt Damon was up there having a big storm hit him, we were saying, that's so unrealistic. Well, it's pretty realistic. There's a huge storm on Mars right now. And Opportunity, this is what you're seeing is the Mars orbiting reconnaissance orbiter is taking these pictures so you can see the storm from its point of view. It's spreading, it's getting bigger and bigger. So Opportunity has shut itself down until it can get enough solar power to come back up again. There's no end in sight at this point. But Curiosity is doing fine because it has nuclear power. So what did Mars house life? Well, we don't know yet. We found the conditions, but now we're going to go back, and we're sending this guy. This is called Mars 2020, and it's our next rover on Mars. You can see it looks kind of like Curiosity, but it has very different instruments on it. It will have the giant robot arm, has bigger wheels, so it can climb steeper slopes, and it has microphones, so we can finally hear the sounds of Mars, or at least the sounds of Mars 2020 engine, and it can make oxygen, which is another thing when Matt Damon is up there next time. Now he can know where to get his oxygen from. But for long space flight, we're going to figure out how to make oxygen. And it's going to store materials that it finds for a future spacecraft to land, write out, get it, send it back up, and take it to Earth. That's the idea, so we can get Mars samples from Mars. And it's going to have a little buddy. It's going to have a helicopter on it. So the Mars helicopter will pop over, look at the hills, and come back and tell Curiosity, or Mars 2020, if it should go there or not. It's an experiment. Will it work? We hope so. But I love that NASA is willing to try it. It's like flying a helicopter at 100,000 feet, because Mars only has 1% of our atmosphere. So it's a very difficult thing. Now, if we one day needed to export humanity, would we have a place to go? We have actually found planets, Earth-like planets, where water could be liquid, about the size of Earth compared to our sun. They're just really far away. So we have to get better propulsion. It'll take us about thousands of years to get there with today's propulsion, but we're getting there. We're fixing it. Today, we're looking through a straw at the single space in the sky to detect the wobbles. That probably means that it's a planet orbiting a sun. Tomorrow, we're going to have these huge apertures. So how we're going to possibly calculate and store all that data? Cloud computing. So it's really helping us. And who's going to figure out how to do it? You all. So thank you for that. Have you ever heard of Psyche? It's like, well, we're going to go. It's a metal asteroid, completely out of metal. And it's like if you could take Earth and strip the skin off and just look at the inside, that's what we have the opportunity to see for the first time ever. And that's a lot easier than stripping the skin off Earth. So that's going to be exciting. So we have these launches coming up, and hopefully you will all be participating in these. But we need to change. We need to figure out preparing for the next generation of explorers, working differently. We want to have this crowdsourcing, participation. We want you to participate. How we're going to do that? Augmented reality is one. We already are able to meet on the surface of Mars, looking at rocks. We're able to look at spacecraft, make sure that our hands can fit in to turn the screws before we build it. But that's only the beginning. We had at reInvent 2017, so about 6 months ago, we showed this rover, and the rover was built by students, and it was able to drive. We simulated, we built a Martian wall. Anybody was there? Anybody went and saw it? Clap your hands if you did. Too few. But what we were able to do is to simulate a diverse robotic swarm and actually do it. So we pushed the edge the year before with green grass and Amazon to kind of microprocessor sized. This year to microcontrollers. So now these little puffers that you'll see in a second, the climbers and the puffers were little tiny robots, kind of disposable, that could climb walls. They were specialized. And then they sent telemetry back to the middle-sized rover that then got its intelligence from the cloud as it needed to. Very different mentality. And it was an experiment. It was fun. Now, if you think about that, how about if we could push the edge all the way out into space? What if this was the moon, and you have the lander now using these small disposable rovers, the puffers in this case, and they are doing exactly what we did on stage. One climbed up, saw the lay of the land, reported to the others, who then decided to go and experiment. Some got stuck, but in the end we found life. And for you who were there, it was of course Matt Damon. But now they can then send telemetry back to the lander that then gets its instructions from Earth or by itself. So it's the edge computing really pushed far away, and it's completely autonomous. That's the key. So we want you to participate. So what we're doing now is we're going to open source this rover, and we're going to have people participate and help build it, and we've already done it. There have been 5 schools already that participated and built it, and they've already improved it and adding a lot of features and capabilities. And that's the new way of working, we believe. So if you look at, Mick and I were showing some Cub Scouts boys, so we had to calm them down. So we said, give us the biggest rock pile you can make. And if you notice this thing, it's built by students. It climbed perfectly, because it was built just like the real thing was. Here's one that may one day go to Europa. It was a prototype for that. See, the same construction. This was built by the expert. So how did we do that? We used those experts as advisors to the students so that they could then build it in the right way and now be prepared to enter the workforce and be engineers and scientists. On this, you can also plug in your own science experiments. So for classes, budding scientists can learn and do various experiments. Engineers build it, and it's cheap enough. That was one of our key things. Cheap enough where schools can afford it. And already before it's even live, people have figured out how to make it 10 times cheaper. So that's the power. That's what you can all give us. And it's going to be, simply put, awesome. So I want to thank you for your attention. And if you want to talk about some of the other trends or anything like that, there are several JPLers in the audience, especially up here in the front row. And they are the experts. So thank you very much for all that you do. Please help us answer the big questions. And I believe that those big questions will be answered in my lifetime. So keep me alive. Thank you very much for your attention.
Thank you so much, Tom. All right, I hope you guys had a fantastic day today. Let's have one more round of applause for Tom Soderstrom. I always feel like whenever I hear Tom speak, like I've been listening to Thomas Edison or something. He just really epitomizes the idea of a builder for me. So tomorrow 9 a.m., we will start with our technical sessions. I hope you'll all come back. We have a jam-packed day. And we'll have an incredible closing party right here at 4 p.m. So please come back again tomorrow and go on and build on. Thanks.